Okay, now while I stepped out for a minute to get some ice, I asked you to think this through, so I'm sure you did. And you came to the conclusion that since the total voltage change around this loop is 0,
That's what I said.
that voltage source plus the voltage drop here plus the voltage drop here has to add up to 0, meaning voltage of the source is the sum of these two voltages. You just do a loop, right? Okay? And VC is just Q over C, so that's I max over omega sine of omega t plus, well, what's the voltage across the resistance? Now you can start with conductivity. Yeah.
Isn't VC supposed to have the value that's supposed to have a C in there? It's Q over C.
I'm sorry.
Is it not Q over, is VC not Q over C? Because you didn't include a C on the IMAX portion.
Yeah. Sorry. Okay. Left the C out. Okay. It's Q over C. Okay, what's the voltage across the resistor? I keep pointing to this and calling it the resistor. I don't know why. I'm not looking, that's why. Okay? What? How do you get the voltage across the resistance? If you know the current through the resistance, how do you get the voltage? Well, it's current times resistance. Okay? And you should be able to reason that out from the whole concept of conductance and what voltage means. Potential difference, joules per coulomb energy, right? Make sure you can do that because it's likely to show up on a test. Okay? So this is then VC over R, I times R, which is
Well, I put the negative sign there.
right? Now where is sine of omega t? Well, sine of omega t would be projected over here, right? Make sense? You know, unit circle, you need to understand that if you don't. I think you do. Okay? Well, I don't want to write it like this. I want to write this as, first of all, I max times 1 over omega c okay, the sine of omega t is the cosine of omega t minus phi, right? Or minus pi over 2. Okay? So we have this, and this cosine of omega t minus pi over 2 can be depicted on this very picture like so. If this is omega t, then this angle here is omega t minus pi over 2. Make sense? Well, we put this all together and we multiply the cosine of omega t, which is this, by R, I max times R. Okay? And we multiply the cosine of omega t minus pi over 2 by what?
1 over omega c.
Times I max, right? Okay? Well, this is going to give us a picture like this. You got two circles. One's going to have radius, and let's leave I max out of it. One has radius r, one has radius 1 over omega c, right? Okay? So I don't know, which one do you want to be r, which one do you want to be 1 over omega c? Well, I'm going to make this radius r here. And I'm going to let this one, kind of coating it in green, to go along with the circle I've got here and the green I've got here. Okay? I'm going to call this radius one over omega c. Okay? And then I'm going to draw my arrows. Wherever this arrow is, this one is 90 degrees behind it. So, just to generalize, I'll put this one out here, okay? And I'll put this one at 90 degrees to it right here. Okay? Now, as these things go around the circle with a frequency of 1 over omega over 2 pi, okay? Omega being the angular frequency, right? Go around the circle with their frequency. I'm going to have a voltage across the capacitor, which is going to be like this point on the axis, and a voltage across the resistor, which would be like this point on the axis. Okay? Now, if I want the radius to be r times I max, and I max over omega c, I can do that as well. Okay? But I kind of want to focus on r and reciprocal omega c. And also what happens here, because now what's the result of these two vectors? Where's the result?
To the left of the origin. And up.
In the second quadrant, you mean?
Yep.
Yeah, we just add this vector to this one. We get a vector that's a little bit longer than this. Okay? And it'll be going around this circle. And I max times this vector is going to be the voltage of your source. Here's your capacitor. Here's your resistor. Here's the resultant of what you get when you add these two. Okay? That's the phasor diagram. So, got that idea? The rest is fairly simple if you can add sines and cosines of different phases. Okay? And of course you need the sum of two angles formulas to do that.
So what does a phasor do?